Welcome back, everybody. This is episode 15 of my multi-cloud network architecture series, and in this episode, we're going to be talking about NAT for cloud applications. As organizations move their applications to the cloud, build new applications in the cloud, and provide these applications as a service to their customers and to partners, we're coming across a scenario where NAT is required. But the problem we face is that no cloud service provider offers NAT like we need it. No advanced NAT, no policy-based NAT, no SNAT, DNAT, customized NAT functionalities. They really only support super basic NAT functionalities, nowhere near what enterprises truly require for their cloud network architecture. So today, I've invited special guest Nicolas Delecroix. We've had him before. He's a fantastic resource at Aviatrix, and I'm super excited for him to talk to us about what he's been working on with his customers around NAT. Thank you so much for being here, Nick.
Hey Dana, thanks for having me. Yeah, this architecture is for anybody who is in the cloud and is hosting shared services in the cloud. You want to provide those shared services to multiple customers who are going to send data, consume the service, but those customers are completely separate, and so they could very well have overlapping IPs. Mm-hmm. And so on-prem, we've been doing NAT to handle that challenge for a long time. Yeah. But in the cloud, with the native cloud networking constructs, there is no NAT. It doesn't exist. Mm-hmm. So this is where Aviatrix comes in. We have a very powerful, very flexible NAT functionality to handle this use case.
Yeah, Nick, I run across this problem pretty often with my customers. Nobody has control over what their partners or their customers are running from an IP address space perspective. Everybody uses RFC 1918 space and nobody's coordinating with each other. And when it comes time to provide connectivity between these different entities, you're going to run across overlapping IP address problems. And so having a really rich suite of NAT tools is crucial in the cloud. This provides you that enterprise level networking functionality. So Aviatrix is really bringing enterprise functionality to the cloud like you've never seen before. And this scenario seems to be really interesting because you actually have these isolated pods where the customers are accessing their own dedicated resource in their pod, and they don't have to talk to another customer, so they can stay within that pod and there's no overlapping IP address problem. However, when they egress that pod and go to the shared services pod, there's definitely going to be overlapping IP address problems. So you have to have the NAT functionality there, right?
Exactly, that's exactly what happens, Dana. This shared services is accessed via Aviatrix Active Mesh Transit. So here we're going to NAT anything that's going towards the shared services, mm-hmm. which, by the way, there's also presence of those services in GCP. That's going to go across the transit peering, but for anything that is local in their isolated pods, there is no need for that.
Yeah, we have that flexibility in a policy to say, hey, if you're going to just your local service in your local pod, don't do any of that. Mm-hmm. But if you're trying to go to anything else, or maybe to something in that shared services or in GCP, NAT to some specific IP, whether it's whatever IP you specify. It could be a public IP, it could be a private IP, or if it's just the IP of the gateway itself to make life easy, right?
Exactly.
Okay, that's awesome. And then you have GCP here as well, because you might take your resource and place it in GCP because it just runs better there. And I think that's pretty common with AI to run it in GCP because they have a platform that's optimized for that. And so now you need to figure out, how do I handle NAT cross-cloud, not just within the same cloud? And when you build this normalized data plane using Aviatrix, you get all those tools, whether it's within a region in the same cloud, across regions in the same cloud, or across multiple clouds. You have the same set of tools everywhere. That blows my mind. It's really powerful.
So you see, in this architecture, we give customers their own isolated pods, mm-hmm. which in the cloud is a VPC. The first advantage is it's reducing the blast radius as much as possible. They land on their own gateway and they have their own service on top of the shared services, that the service can be as large or as small as required. Mm-hmm. The second thing is we can use the role-based access control on the controller. So we can the VPCs could actually belong to the accounts, the AWS account of the customers, but we can onboard those accounts on the controller and launch the gateways there. And finally, it helps for the billing as well, because you separate the accounts, so you have a better visibility on the billing perspective on a per customer basis.
Oh yeah, that's cool. So you can provide really clear chargeback because the data transfers, the connectivity model, everything is tied to a single account, and that single account might be tied to a specific customer. And you can have multiple accounts. A single controller can handle hundreds of accounts. And then, like you said, an account can be tied to a particular role or access control in the controller as well. And so you can control who's able to do what per account. And that's pretty, or per customer. That's really, really cool.
Yeah, absolutely.
So Nick, this looks kind of complex, but I know from my experience it's actually really easy to configure in our controller. Can you show me how you did it?
Yeah, absolutely. So if we go to the controller, we see here in the site to cloud, this is where we have the connections back to our customer. So for example, this is the one back to customer one. And this is using the gateway, C1 site to cloud gateway.
Mm-hmm.
And so we can simply go here and take a look at that gateway. And you see what we do is very simple. Under source NAT, we have selected the customize SNAT.
Yep, I see it.
And so the source could be anything. What matters to us is anything that is going to the shared services of AWS or the shared services or GCP is going to be NATed, because remember that 1061, 10141, this is the 1061 here, and this is the 10141.
Right, and everything else just don't NAT it, let it pass unnatted, right?
Exactly. So then what the role is going to be is SNAT with the private IP of the gateway, which is actually an IP that belongs in that VPC.
Yeah.
So the 1062, and we know that for sure is unique because we have created that VPC ourselves.
Right.
And so we can guarantee that it does not overlap with any other VPC from our AWS environment.
Yeah, that's really cool. So this is the policy, behavior, or mechanism of our NAT that you can create these rules, and they're based off these specific requirements. It has to be from a specific source, going to a specific destination, and then it can NAT to a specific IP. And I even had a customer that didn't use private IPs. They actually leveraged their global unique addressing, their public IP space with the cloud, and they were NATing to their own public space, which was really interesting use case, but it solved their problem.
Yeah, you could do that as well. Yeah.
Awesome. And we also have port address translation built in. So NAT overload. I was playing with that the other day and it works seamlessly. It was really awesome to be able to leverage PAT, dynamic PAT.
Yeah, absolutely. Now, we said we have services hosted in GCP as well. So how do we get to those services? Remember, they are just here in the topology here. All we need to do is to build this transit peering between the Aviatrix transit gateways in AWS and the one in GCP. And it's very easy to do, as you know, transit network, transit peering, and it's actually right here. That's the second one. Yep. But you see, to build it, it's as simple as doing add new, selecting, the first transit gateway, the second transit gateway, click OK.
Yeah.
That's amazing.
It builds it all for you. I love that. It configures the IPsec, it configures the routing, everything end to end to build that connection between the two clouds.
Yeah, exactly. And much beyond just the IPsec, right? It's the entire control plane.
Oh, true. Yeah.
Because, it has learned that the 10141 is attached to our transit.
Yep.
It knows that it needs to make that 10141 available also from the VPCs as necessary in AWS. Automated propagation across different clouds.
Yeah, just like I thought, super straightforward configuration to get all of this end-to-end connectivity to occur and all the NATing. It's really anybody can pick this up and configure it successfully. Now, I'm curious, can you show me this in action, in real time?
Yeah, let's do it. We're going to show first the most basic use case. We're going to log in to the customer on-prem server. So this one here for customer one, and we're going to ping the local service. That's the most simple, we're going to go across the site to cloud. And we'll do a packet capture here on this VM to show, that the ping arrived and there's no NAT.
Got it.
And then we'll show this one, and then we'll show GCP, okay?
Perfect, let's do it.
So I'm going to launch terminal, and we actually use AWS also to simulate the on-prem. So we'll go to the C1 on-prem VM. Okay, and as you can see, this is the 192.168.69 IP.
Perfect.
Okay, so we're going to do a ping of that local service here. So that's our 1062.79.79. So it's actually great because we see the ping is working.
Yep.
So we have connectivity, but now let's actually log into that VM itself. So that's our cloud app VM. Okay, and we confirm this is our 1062 VM.
Yeah.
So now what it means is we can do a TCP dump on ping, and we can actually confirm. You see, this is not NATed. This is the real source IP.
Perfect. Yeah, exactly. Just like we expected. No NAT translation because the policy said don't translate unless you're going to the shared services in AWS or GCP. But in this case, it's not a shared service. It's that dedicated service.
Exactly.
Perfect.
Good. So this is working. So now what are we going to do? We're going to ping the shared services. So this is our VM here on the top. That's 1061.78.248. Good. This is working as well. So let's SSH to this one, which is our shared services VM. And again, we can confirm that's the 1061. So now we notice that we see the ping coming in, but what's the source? It's been NATed, right?
Yeah.
The overlapping IP has been hidden and replaced by an IP that is unique. This is this one. This is actually the gateway IP.
The IP of the gateway, yeah. That's like you said, we know that one is not going to overlap because we control those IPs internally.
Exactly. It does not overlap because you see for the customer 2, of course, we gave a VPC with a different IP that would be 1063. So we know we're going to be okay.
Perfect. That's beautiful. Okay.
And the last test we're going to do is I'm going to move the window here because, from that on-prem VM, now we are going to ping the GCP shared services. That's in 10.141. So I'm going to do 10.141.03. And we see this is pinging.
Higher latency, so you know it's going over the transit.
Yeah, it's true. So you see then from our on-prem VM, indeed, we are able to ping the shared services hosted in GCP.
Yeah.
So let's SSH to these GCP shared services. Actually, we'll SSH and we'll start the TCP dump. Actually, let me resume the ping. Then go back here and we'll do a TCP dump. Yep. As expected.
There it is, translated to 149. Yeah.
Translated to an IP that's unique, and so we are resolving using that this overlapping IP challenge.
Fantastic. Yeah, this solution works pretty flawlessly.
Okay, then so you see what's cool also is this entire infrastructure. If you want to, you can completely automate using Terraform. We have a repository on GitHub called Aviatrix Solutions, and this one is actually here under multi-tenant SaaS. And you see how this is building the entire topology. This is building the VPCs, the transit gateways, and the site to cloud connections and all of that. So we could do a little fun game. Is I could go on the controller and we could remove something. We can actually break it, and then let's take Terraform and we'll run Terraform to see it's going to be smart enough to notice the delta of what we just removed, and it's going to put it back.
That's a cool test. Let's do that.
All right. We could go on the gateway. We could actually remove the SNAT. What do you think?
Yeah, let's do that. Let's kill SNAT. Maybe somebody was in there messing with the policy and they removed SNAT and broke everything.
Yeah. Okay. So we're going to go here. We're actually going to completely disable SNAT.
Okay. Okay, so that breaks connectivity now.
It's going to break connectivity, yeah, because see, I could go back to my on-prem VM and see now if I'm trying to ping, let's say the GCP shared services, or actually even the GCP shared services, that wouldn't work because GCP and the entire network, they don't know, they have no idea about that 192.168 IP.
Right.
We don't want them to know because this is overlapping with somebody else.
Yeah.
So as expected, see, we do that ping now, it doesn't work.
Right, it's broken, has nowhere to go.
It's broken.
Yeah.
So what we're going to do is open a different window, okay? And I'm going to log into a Docker image where I have my Terraform solutions, okay? This is the same as the GitHub. I'm going to just actually make it larger. And you see I'm going to do Terraform apply.
So it's applying the Terraform script that you showed us earlier. That's the SaaS, multi-tenant SaaS script.
Yeah. Okay. But now what's really cool is look at how many things it's checking. It's the entire config. The entire config, and it's state aware. So it knows, hey, most of the states, it's going to notice most of the states is okay. But look, it has actually noticed what is missing.
Holy moly, that is powerful.
Yeah, it's amazing. You can see, oh yeah, on that specific customer one, site to cloud customized SNAT policy. This is on that specific gateway that we just removed it. And those are the two policies we were missing. So of course, yes, we would like to perform these actions. And so this is creating it. Look, that's done. It basically just took 10 seconds. Now, if we go back to the controller, maybe I'll just go back to the gateway page. That was on this gateway, we removed it. But as expected, this is back.
And the connectivity should work now, right?
It should work. So let me just put that window back on the side. And we're back.
That's so awesome. You could even have the script run periodically to make sure things are how they should be, that your state is how they should be, right?
Yeah.
Really cool. Love it. Nick, this is awesome. I want to drive home one point, however. The fact that none of this would have been possible without the Aviatrix networking platform. Native cloud service providers don't provide any of the tools needed to meet these types of enterprise requirements. You don't have NAT, you don't have packet capture, you don't have any automated route propagation end-to-end within the cloud. You don't have the visibility and the troubleshooting tools you need to make this happen. So I want people to realize that you truly need an enterprise platform like Aviatrix to meet these requirements, to get what you were doing on-prem to work in the cloud as well. So with that, Nick, I want to thank you for being here again with me. It's always a pleasure to have you on this YouTube channel. I'm sure I'll get you back in the future for another use case.
Thanks again for having me, Dana. Great pleasure. See you soon.
And as always, we're going to end talking about what Aviatrix did for us in this scenario, and it's pretty straightforward. Aviatrix provided strategic places in the network to implement policy-based source NAT and destination NAT functions. And this is really powerful because today there's no cloud service provider out there that supports NAT in the way that most enterprises need in order to meet their business and technical requirements. It's mandatory to have more intelligence in the cloud, and the only way to get that intelligence is by leveraging the Aviatrix gateway architecture, our data plane, our control plane. We give you everything you need to have the tools to be successful in the cloud. And then we were able to leverage Aviatrix to build the global multi-cloud backbone. As you saw, Nicolas was leveraging this NAT functionality in AWS and in GCP, but you could leverage this NAT functionality in any cloud, Azure, OCI, whatever. And lastly, Aviatrix handled the route propagation. We didn't have to worry about configuring routes anywhere. The controller did it all for us. As always, I want to thank you all for being here with me today. I look forward to having you in the next one. Take care.